To all of you. In the last lecture, we have discussed the test question paper. Okay. Then now in this class we going to start the scalar matrix point. Already we have discussed here. These are concepts of the diagonal matrix and their properties. Then we have also discussed the some triangular matrix, upper triangular matrix, lower triangular matrix. Okay, strictly upper triangular matrix, strictly lower triangular matrix. These are all discussed here. Now we are going to discuss the a scalar matrix. How to first we see the definition of the scalar matrix. In nodri, a scalar matrix is a diagonal matrix. Okay, in nodri, a diagonal matrix is said to be a scalar matrix if all the diagonal elements are same. A diagonal matrix A is said to be scalar matrix if all diagonal elements are same. Okay, that is called in the scalar matrix. You know already diagonal matrix. Diagonal matrix andre enri. Suppose if you take a diagonal matrix here, then D1, D2, these are the diagonal elements and remaining elements are 0. That is called a diagonal matrix. Okay, it is a diagonal matrix. And this diagonal matrix becomes a scalar matrix if all the diagonal elements are 0. Sorry, equal same. All the diagonal elements are same. D1, D2, Dn. D1 is equal to D2. D2 equal to D3. Definition of the diagonal matrix. Scalar matrix. A diagonal matrix A is said to be a scalar is said to be a scalar matrix if all diagonal elements are same. Then that diagonal matrix is becomes a scalar matrix. ಅಂದ್ರೆ ಇಲ್ಲೊಂದು diagonal matrix ಅದ ನೋಡ್ರಿ d1 diagonal elements are d1 d2 dn and remaining non diagonal elements are 0. Okay, this diagonal matrix is said to be a scalar matrix if all the diagonal elements are same. d1 is equal to d2, d2 equal to d4 and so on dn. ಇವೆಲ್ಲ diagonal elements ಎಲ್ಲ ಸೇಮ್ ಇದ್ದು ಅಂದ್ರೆ then that diagonal matrix is a scalar matrix. Okay, ಇಲ್ಲಿ ನೋಡ್ರಿ ಎಕ್ಸಾಂಪಲ್ ಆಗಬೇಕಂದ್ರೆ ನಿಮಗೆ a is equal to 1 1 2 by 2 it is a scalar matrix because diagonal elements ಎರಡು ಸೇಮ್ ಅದಾವ, non diagonal elements ಎಲ್ಲ 0 ಅದಾವ. Therefore it is a scalar matrix of order 2. a2 2 2 and remaining all elements are 0. It is also scalar matrix of order 2 by 2. Then a3 1 1 1 and remaining all elements are 0. It is a scalar matrix of order 3 by 3. Okay, and so on continue in this way. All scalar matrix of order 2 3 whatever. In nodri diagonal elements are same ಇರಬೇಕು, non diagonal elements are 0 ಇರಬೇಕು, then that matrix is called a scalar matrix. Then if you take any general scalar matrix here, ಏನು ಮಾಡ್ತೀನಿ ನೋಡ್ರಿ ಇಲ್ಲಿ, A is equal to, it is also diagonal matrix, its all diagonal entries are same, D, D1, D1 and so on, Dn, D1. It is a scalar matrix of order n and all the diagonal elements are same here. Okay, then ಇದಕ್ಕೆ ಹೆಂಗೆ ಬರಿಬೋದು ನೀವು, this can be written as D1, D1 and D1. Here remaining all the elements are 0. Okay, this is the diagonal matrix with the diagonal, all the entries are same, D1, D2, Dn. Then that matrix is called a scalar matrix. Okay, then if you take the D's same here, then we can take the D is common, take outside the matrix. ಏನಾಗ್ತದೆ ನೋಡ್ರಿ ಇಲ್ಲಿ, D times, then what is remaining here, if you take the D is common, then here is diagonal entries are 1, 1, 1 and remaining all the elements are same, 0. Okay, then, and you know already this is a square matrix with all diagonal elements are 1, and that matrix is called an identity matrix, that is IN. ಏನು ಕರಿತೀರಿ ಅದಕ್ಕೆ, identity matrix of order n. Okay, that is a scalar matrix. Okay, ಇಲ್ಲಿ D into IN, IN is identity matrix of order n. ಏನು ಕರಿತೀರಿ ಇದಕ್ಕೆ, all the diagonal elements are 1 ಇದ್ದು ಅಂದ್ರೆ and remaining all the elements are 0 ಇದ್ದು ಅಂದ್ರೆ that matrix is identity matrix. Identity matrix of order n. Order n. Then if you take any scalar matrix of order n, that can be written as D into n. D1, not here D, D1 into IN. Every square matrix, every scalar matrix can be written as D1 into IN. ಯಾವ್ದು ಬೇಕಾದ ತಗೋರಿ ನೀವು scalar matrix, that can be written as the diagonal element into IN is always a scalar matrix. Okay, then it is the first point. Second is, scalar matrix is always commutative with every other matrix. Okay, if A is scalar matrix, A is scalar matrix, then A into B is equal to B into A for all B. For all B. ಅಂದ್ರೆ ಏನ್ರಿ, scalar matrix is commutative with every other matrix. ಹಂಗೆ ಬರೀತೀರಿ ಇದಕ್ಕೆ, every scalar matrix is commutative with every scalar matrix is commutative with every other matrix. Okay, then these are the some theory about the scalar matrix. A diagonal matrix whose each diagonal elements are same is known as the scalar matrix. Definition is there, and S is equal to a diagonal matrix with all diagonal elements are same. K ತಗೊಂಡಿದೆ ನೋಡ್ರಿ ಇಲ್ಲಿ, It is a diagonal matrix adu ಮತ್ತು scalar matrix ಅದು ಯಾಕಂದ್ರೆ all the diagonal elements are same ಇದ್ದಂದ್ರೆ that diagonal matrix becomes a scalar matrix ಆಗ್ತದೆ. Okay, then ಇದಕ್ಕೆ ಹೆಂಗ್ ಬರೀತೀರಿ ನೀವು ಇಲ್ಲಿ this types. Okay, k diagonal elements are there and non diagonal elements are 0. Then take k outside, k and madri take outside, then remaining it is these are all elements are 0, it is also these elements are 0. Okay, then k into in is where in is identity matrix in करित्री इसका in का is identity matrix of order n, identity matrix of order n. Okay, then one more condition, if A is any general matrix then AS is equal to SA. AS is equal to SA andre enri A into scalar matrix is same as scalar matrix into A. It means what here? Scalar matrix commit with every matrix of its order. Ada scalar matrix commit with every matrix. Okay, scalar matrix commit with every matrix of its order. Okay, it is the first condition. Then number of non-trivial entries in set of all scalar matrices of order n is always 1. Okay, if you take any generally scalar matrix of order n then it has only k is non-trivial entries. Okay, ಇಲ್ಲಿ ಒಂದೇ ಅದು ನೋಡ್ರಿ ಎಲ್ಲ ರಿಮೈನಿಂಗ್ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ 0 ಅದಾವ and diagonal elements ಎಲ್ಲ ಸೇಮ್ ಇರೋದ್ರಿಂದ k is only non-trivial entries. Okay, therefore in scalar matrix how many non-trivial entries? Only one non-trivial entries. Okay, and if you take the all the scalar matrices hang ಬರಿತೀರಿ a into k times in, a into k times in, every scalar matrix can be written as a is equal to k times identity matrix. Okay, then it is a set of all the scalar matrices is there, then its forms an vector space and its dimension is 1 because every it has only one non-trivial entries to represent a scalar matrix, that is diagonal elements. Okay, all the diagonal elements are same, then that is the only a non-trivial entries. Okay, ಇಲ್ಲಿ ನಿಮ್ಗೆ ಯಾವುದೇ ಒಂದು ಸ್ಕೆಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಬರಬೇಕಂದ್ರೆ ವಿ ಹ್ಯಾವ್ ರಿಕ್ವೈರ್ಡ್ ಓನ್ಲಿ ಒನ್ ಎಲಿಮೆಂಟ್ ಹೌದಲ್ಲ. ಇಲ್ಲಿ ನೋಡಿ ನಮ್ಗೆ ಇಲ್ಲಿ ಒಂದು ಸ್ಕೆಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಬರೀಬೇಕಾದ್ರೆ ಏನು ಬರಿತೀರಿ ನಾವು ಇಲ್ಲಿ a is equal to we have, if you know one element then you can easily write. ನಿಮ್ಗೆ ಇಲ್ಲಿ -1 ಗೊತ್ತಿತ್ತಂದ್ರೆ -1 -1 -1 by using remaining elements ಎಲ್ಲ 0 ಕೊಡ್ತೀನಿ ನಾನು. Okay, then and by using only single element we can write the a scalar matrix of order 3 ಹೌದಾ, and other -2 -2 -2, here is 0, here is 0, then only we can write it is scalar matrix. Okay, I hope all of you understand this scalar matrix concept. Next nodri, next is the identity matrix or unit matrix. Again karitri identity matrix or unit matrix is there. A scalar matrix whose diagonal entries is equal to 1. Okay, identity matrix andre enri ಅದು ಸ್ಕೆಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇರ್ತದೆ. A scalar matrix whose diagonal entries is equal to 1 is known as unit matrix or identity matrix. It is denoted by in of order n, capital I suffix n, that is the identity matrix of order n. Okay, here it is in is equal to hang ಬರೀತಾರೆ ನೋಡ್ರಿ identity matrix of order n. Of order 2 ಹೆಂಗ್ ಬರೀತೀರಿ I2, that is 1 1, diagonal elements all are 1, non diagonal elements are 0, that is identity matrix of order 2. Order 3 do 1 1 1, 3 diagonal elements are 1, remaining all elements are 0, Okay, then I4 1 1 1 1, then remaining all elements are 0. It is identity matrix or unit matrix of order 4 by 4. Okay, then here how many non-trivial entries are required? Okay, arbitrary ಯಾವುದು ಇಲ್ಲಿ ಫಿಕ್ಸ್ ಅದ ನೋಡ್ರಿ, 1 ಅದ, ಅದು ಫಿಕ್ಸ್ ಅದ ಇಲ್ಲಿ. Okay, and it is fixed ಇತ್ತಂದ್ರ that is not an arbitrary non-trivial element. ಇಲ್ಲಿ 0 ಫಿಕ್ಸ್ ಅದಾವಲ್ಲ, ಹಂಗೆ ಇಲ್ಲಿ 1 ಫಿಕ್ಸ್ ಅದ ಇಲ್ಲಿ. That's why it has no non-trivial entries. Okay, non-trivial entries ಅಂದ್ರೆ ಏನು? ಅದು ಆರ್ಬಿಟ್ರ್ ಆಗಿರಬೇಕು, ಚೇಂಜ್ ಮಾಡ್ತಾ ಇರಬೇಕು ನಮಗೆ. ಓಕೆ, ಇಲ್ಲಿ 0 ಫಿಕ್ಸ್ ಅದಾವ, 1 ಫಿಕ್ಸ್ ಅದಾವ. These are fixed numbers, not arbitrary or not non-trivial entries. Okay, that's why the non-trivial entries in set of all the identity matrix ಎಷ್ಟು ಅದಾವ ಅಂದ್ರೆ 0, ಯಾವುದೂ ಇಲ್ಲ. There is no non-trivial entries. Okay, ಇಲ್ಲಿ ಬರ್ತೀನಿ ನೋಡ್ರಿ, note, there is no non-trivial entries as only element 1 which is fixed. Okay, ಒಂದೇ ಎಲಿಮೆಂಟ್ ಅದ್ರಿ 1, ಅದನ್ನು ಇದೆ ಫಿಕ್ಸ್ ಅದ. Okay, this is all about the identity matrix. It is very easy. Then identity matrix is also commute with every matrix nodri, because it is scalar matrix alla. Identity matrix is also called scalar matrix. The identity matrix is special case of a scalar matrix. Okay, the scalar matrix ಒಳಗೆ ನೀವು diagonal elements ಎಲ್ಲ 1 ಇಟ್ರಿ ಅಂದ್ರೆ that becomes an identity matrix. That's why the identity matrix is special case of scalar matrix. Then you know already any scalar matrix commute with any other matrix. In particularly IN is also a scalar matrix is there, that is also commute with any other matrix of same order. A into IN is equal to A and IN into A is equal to A. Okay, this is all about the identity matrix. Next we go to the idempotent matrix. ಏನು ನೋಡ್ರಿ, idempotent matrix. First we see the definition. The idempotent matrix definition nodri, a square matrix A is said to be idempotent if A square is equal to A. ಅಂದ್ರೆ ನೀವು ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ರೆ ಅದೇ ಬರಬೇಕು. A square is equal to A, ಎರಡು ಸೇಮ್, A square ಮತ್ತು A ಎರಡು ಸೇಮ್ ಇದ್ದು ಅಂದ್ರೆ that square matrix is called idempotent matrix. ಹೌದಾ? ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡ್ರಿ, ಇಲ್ಲಿ A is equal to 1 1 0 0. Okay, square ಮಾಡ್ರಿ. What is A square? A square is equal to 1 A into A. ಹೆಂಗ್ ಬರೀತೀರಿ? A square is A into A. That is equal to, what is A? A is 1 0, sorry, A is 1 1 0 0. Then again A is 1 1 0 0. Multiply these two matrices. ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, ಈಗ first row first column 1 into 1 1, 1 into 0 0, therefore it is 1. Next first row second column 1 into 1 1 plus 1 into 0 0, therefore it is 1. Next 0 second row first column, already second row is 0 is there, therefore it is, these two elements are 0 0. But ಏನಂದ್ರೆ ಇದು, it is equal to A given matrix. Okay, ಮತ್ತೆ ಇದಕ್ಕೆ ಏನು ಕರಿತೀರಿ ಈಗ? A square equal to A ಬಂತ? Then this implies that the A is idempotent matrix. Okay, I hope all of you understand this example of the idempotent matrix. ಇನ್ನೊಂದು ತಗೋರಿ, A2 is equal to 0 0 0 1 1 1 0 0 0 ನೋಡ್ರಿ ಚೆಕ್ ಮಾಡ್ರಿ ಈಸ್ ಇಟ್ ಐಡೆಂಪೊಟೆಂಟ್ ಆರ್ ನಾಟ್ ಏನು ಮಾಡ್ಬೇಕು ಅವಾಗ you must find out a2 square, that is a2 into a2. What is a2? 0, first row 0, second row all elements are 1, third row all elements are 0, that is a2. Next again same matrix is there, 0 0 0 1 1 1 0 0 0. Then ಇಲ್ಲಿ ನೋಡ್ರಿ first row 0 ಅದ, therefore all first elements are also 0. in a square ಒಳಗೂ first row ನು 0 ಇರ್ತದೆ, last row nu third row nu 0 ad nodri illi, therefore in a square the third row is also 0. Then what about the second row? Multiply second row first column madri, 1 into 0 0, 1 into 1 1, 1 into 0 0, therefore 0 plus 1 plus 0, that is 1. Second row second column, 1 into 0 0 plus 1 into 1 1 plus 1 into 0 0, that is equal to 1, again it is 1. Next second row third column, again it is 1, therefore it is an a2 matrix. a2 adan nodri, okay, therefore this implies that a2 is a2 square equal to a2 bantu. This implies that a2 is idempotent matrix. a2 is idempotent matrix. Okay, and so many examples are there. a3 0 0 0 0 0 0 1 1 1, it is also an idempotent matrix. Okay, next the next question is that how many diagonal matrices of order n are idempotent? Andra how many diagonal matrices of order n are idempotent? Diagonal matrix of order n idempotent ಇರಬೇಕು, ಎಷ್ಟು ಅದಾವ ಅಂತ ಕೇಳಿದ್ದಾರೆ ನಿಮ್ಗೆ. ಓಕೆ ನೋಡ್ರಿ ಇಲ್ಲಿ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಯು ಟೇಕ್ ದ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಲೆಟ್ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಹೆಂಗಿರ್ತದೆ ರೀ, ಇಟ್ ಈಸ್ ಎನ್ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ with diagonal entries are a a1 a2 an, because in diagonal matrix diagonal elements are may be same, may not be same, it may be all distinct. Okay, scalar matrix ಒಳಗೆ ಮಾತ್ರ equal ಇರ್ತಾವ್ರಿ, diagonal matrix ಒಳಗೆ diagonal elements it may be distinct. ಹೌದಾ? then ಈ diagonal matrix ಏನಿರ್ಬೇಕ್ರಿ ಐಡೆಂಪೊಟೆಂಟ್ ಇರಬೇಕು. ಅವು ಎಷ್ಟು ಅದ ಕೇಳಿದ್ದಾರೆ ನಿಮ್ಗೆ, ಹೌ ಮೆನಿ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಫ್ ಆರ್ಡರ್ ಎನ್ ಆರ್ ಐಡೆಂಪೊಟೆಂಟ್. ಓಕೆ, ದೆನ್ ಸಪೋಸ್ ಹಿಯರ್ ವಿ ಟೇಕ್ ಎನಿ ಜನರಲ್ ಬಿ ಎ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ದೇರ್, ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇದು ಏನದ್ರಿ ಡಯಾಗನಲ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅದು. ಓಕೆ, then it is also idempotent such that A is idempotent. A is idempotent. If A is idempotent, what is A square is equal to A? Howda? A square is equal to A. Then A is given diagonal matrix. What is A square? A square is nodri. A square is A into A. But A is diagonal matrix is there. That's why its A square is just to square the diagonal elements. A1 square, A2 square and an square. It is an A square is there. A square equal to in bartadari diagonal matrix andra the square of diagonal matrix is very easy. Just to square the diagonal elements, then it is an A square of the diagonal matrix A. Okay. ಮತ್ತೆ ಇಲ್ಲಿ ಏನಂದ್ರೆ A square is equal to A. A square is equal to A. ಅಂದ್ರೆ ಏನ್ರಿ, these two matrices are equal, the corresponding elements are equal ಇರಬೇಕು. Then here in A diagonal elements are A1 A2 an, and in A square diagonal elements are a1 square, a2 square and an square. Therefore, ಏನು ಹೇಳ್ಬೋದು ನಾವು ಇಲ್ಲಿ a1 square is equal to a2 square is equal to, it is a1, it is a2 and so on. an square is equal to an. Okay, equation solve ಮಾಡ್ರಿ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ. ai square is equal to ai ಇತ್ತಂದ್ರೆ then ai square minus ai is equal to 0. Then you take common ai, that is ಏನಾಯ್ತು ನೋಡ್ರಿ ai minus 1 is equal to 0. This implies that either ai is equal to 0 or ai minus 1 is equal to 0. Then this implies that ai equal to 0 or ai is equal to 1. ಏನು ಬಂದ್ರಿ diagonal elements ಇಲ್ಲಿ either 0 or 1. ಹೌದಾ? Here we take any diagonal matrix with diagonal entries are a1, a2, an. Then if it is idempotent, then each ai is belongs to either 0 or 1. ಇಷ್ಟೇ ಇರಬೇಕು. Then ಇಲ್ಲಿ a1 is also either it is true for all I. a1 has two possibilities 0 1. a2 has also two possibilities 0 1, and similarly an has also two possibilities. Then how many total possibilities are there? 2 raised to n possibilities are there. Okay, that's why the number of diagonal matrices ಎಷ್ಟು really number of diagonal scalar diagonal idempotent matrix of order n is equal to 2 raised to n. ಹೌದಾ? ನಿಮ್ಗೆ ಅವ್ರು ಏನು ಕೇಳ್ತಾರೆ ಎಕ್ಸಾಮ್ದಾಗಲ್ಲಿ how many diagonal idempotent matrix of order 2 n equal to ಕೇಳಿರ್ತಾರಲ್ಲಿ. ಅವಾಗ ಏನು ಬರಬೇಕು ನೀವು ಇಲ್ಲಿ 2 square. Okay, 2 square. What are these ಹೇಳ್ಬೋದಾ? 2 square is equal to 4. ಹೇಳ್ರಿ 2 by 2 ದು what are the 4 idempotent matrices are there? Diagonal ಇರಬೇಕಾ ಮತ್ತು. Okay, and entries are either 0 or 1. ಏನಾಗ್ತದೆ ನೋಡ್ರಿ a1 ಹೆಂಗೆ ಬರೀತೀನಿ ನೋಡ್ರಿ ನಾ ಇಲ್ಲಿ a1 0 0 0 matrix. Okay, then it is 1 matrix. Second is identity matrix 1 1 ಬರೀತೀನಿ, it is 0. It is also an idempotent matrix. Third is 1 0 0 0. ಇಲ್ಲಿ ನೋಡ್ರಿ it is also idempotent matrix. a cube square ಮಾಡ್ರಿ ನಿಮ್ಗೆ ಇಲ್ಲಿ a cube ನೇ ಸಿಗ್ತದೆ. And last is a4 is 0 0 0 1. These are the diagonal adavo as well as idempotent matrices are there. Okay, ಇದೆಲ್ಲ ಸ್ಕ್ವೇರ್ ಮಾಡ್ರೆ ಬರ್ತಾವೆ ನೋಡ್ರಿ a1 ಸ್ಕ್ವೇರ್ a1 ಬರ್ತದೆ, a2 ಸ್ಕ್ವೇರ್ a2 ನೇ ಬರ್ತದೆ ರೀ, a3 ಸ್ಕ್ವೇರ್ a3 ನೇ ಬರ್ತದೆ, a4 ಸ್ಕ್ವೇರ್ a4 ಬರ್ತದೆ. Therefore these are the only diagonal as well as idempotent matrix of order n. ಎಷ್ಟು ಅದಾವ್ರಿ ಅವು 2 raised to 2, it is means 4. of order 3 ಕೇಳಿರಿ ಅಂದ್ರೆ 2 raised to 3 2 raised to 3 is equal to 8. There are 8 diagonal idempotent matrix of order 3. Okay, in generally of order n, that time 2 raised to n. Okay, I hope all of you understand this concept. Then ಮತ್ತೇನು ಹೇಳ್ಬೋದು ನೋಡ್ರಿ, one more result is there. If A is idempotent, A is idempotent matrix, then I minus A is also idempotent. is also idempotent matrix. Okay, ignore. A is idempotent is there, then I minus A is also idempotent. Other nodri ga. They given you A is idempotent. Andre entry A square is equal to A kottidare. Then you show that I minus A is idempotent. Andre entry I minus A its square equal to I minus A ಬರಬೇಕು. ಬರ್ತದೆ ನೋಡ್ರಿ ಈಗ. Here I and A are committed to each other. That's why the binomial theorem is holds here. I minus A whole square over 3 I square minus 2A I plus A square. Okay. Then I square is I minus 2A plus A square is A square is again I here. Then that is equal to I minus 2A plus A is minus A. Then but ನೋಡ್ರಿ I minus A whole square is equal to the I minus A. This implies that we can say that easily I minus A is idempotent. I minus is idempotent. ಅಂದ್ರೆ ಏನ್ರಿ A ಒಂದು ವೇಳೆ idempotent ಇದ್ರೆ I minus A is also idempotent matrix. Okay? I minus A is always idempotent matrix if A is idempotent. Okay? Next result. If A is idempotent matrix, then any power of A is also equal to A. If A is idempotent, matrix, ಇದು ಸೆಟ್ ಕೇನ್ ಬಾ ಜಾಸ್ತಿ ಕೇಳಲ್ರಿ ನೆಟ್ ಕೇಳ್ತಾನೆ ಅಷ್ಟು. ಓಕೆ, ಫಾರ್ ಯುವರ್ ನಾಲೆಜ್ ಐ ಆಮ್ ಸೇಯಿಂಗ್ ಟು ಯು, A is idempotent matrix, then A raised to any power, take any power, that is always equal to A, and K is any natural number. K is any natural numbers. Okay, ಅಂದ್ರೆ A is idempotent ಇತ್ತಂದ್ರೆ A square equal to A ಇರ್ತದೆ, A cube is also A ಇರ್ತದೆ, A raised to 4 is equal to also A ಇರ್ತದೆ, and so on. A raised to any K is always A. This result says that if A is idempotent, then A raised to any power of natural number is always equal to A. ಅದೇನ್ರಿ ನೋಡಿ, A is idempotent ಅದ, A square equal to A ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. ನೆಕ್ಸ್ಟ್ ಮಲ್ಟಿಪ್ಲೈ, ಪ್ರೀ ಮಲ್ಟಿಪ್ಲೈಯಿಂಗ್ ಆನ್ ಬೋತ್ ಸೈಡ್ಸ್ ಏನೈತ್ರಿ ಇದು, A cube is equal to A square, ಬಟ್ A square equal to ಏನದ್ರಿ A ಅದ ನೋಡ್ರಿ, therefore A cube equal to A ಬತ್ತಾ. Next again pre multiplying on both sides, A into A cube is A raised to 4 is equal to A into A is A square, but A square is A, then but really A raised to 4 equal to A banta. Next again pre multiplying on both sides, A into A raised to 4 is A raised to 5 is equal to A square, but A square is again A raised to 5 is also A. Similarly A raised to 6 is also A. Then A raised to any power of natural number is always A. It is true only for A is idempotent matrix. If A is idempotent matrix, then A raised to K is always equal to A. Okay. Remember this result. Next is involuntary matrix. As per the next type is involuntary matrix. Involuntary matrix. ಹ್ಯಾಂಗ್ ಡಿಫೈನ್ ಮಾಡ್ತೀರಿ ನೋಡ್ರಿ, A square matrix is said to be involuntary matrix. A square, any square matrix. A square matrix A is said to be involuntary if ಏನ್ ಬರ್ಬೇಕ್ರಿ a square equal to I ಬರಬೇಕು a square equal to in. What is in? In is unit matrix of order n. Okay, in is unit matrix of order n. You square ಮಾಡೋಣ you get the identity matrix of order n. Then that matrix is involuntary matrix. ಹೌದಾ? Examples ನೋಡ್ರಿ ಯಾವುದು? If you take a equal to I, identity matrix ತಗೊಂಡ್ಬಿಡ್ರಿ. What is the square of identity matrix? I square ಏನು ಬರ್ತದೆ ರೀ? I square is I into I, but I into I is I. Therefore, I square is equal to I. This implies that I ಏನೈತ್ರಿ ಈಗ? I is involuntary matrix. Okay? Then, every identity matrix is always involuntary matrix. ಹೇಳ್ಬೋದು ನಾನು identity matrix is involuntary matrix. Okay? Yes. What about minus I? What about minus I? Minus I ಅಂದ್ರೆ ಏನ್ರಿ? All the diagonal elements are minus 1. I n ಅಂದ್ರೆ all the diagonal elements are 1. Okay? Then square it is equal to the ಏನಾಗ್ತದೆ ನೋಡ್ರಿ ಅದು? That is in. Okay? ಗೊತ್ತಾಯ್ತಲ್ಲ ಇಲ್ಲಿ ಏನ್ ಬತ್ರಿ ಇಲ್ಲಿ ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ರೆ ಐಡೆಂಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಬತ್ತು. ದಿಸ್ ಇಂಪ್ಲೈಸ್ ದಟ್ in is also involuntary matrix. Involuntary matrix. I hope all of you understand. These are two examples of the I minus I2. That is minus 1. Remaining all elements are 0. Okay? That is called an involuntary matrix of order 2. Then how many diagonal involuntary matrix are there? Next question. How many diagonal ಇರಬೇಕು, involuntary ಇರಬೇಕು, matrix of order n. Of order n. Okay? ಎಷ್ಟದ ನೋಡ್ರಿ ಈಗ? First of all, you take the diagonal matrix, diagonal involuntary matrix. A ಅಂತ ಗೊತ್ತಿರ ನೋಡ್ರಿ ನಾ ಇಲ್ಲಿ. Let A is equal to ಹೆಂಗಿರ್ತದೆ ಇದು? Diagonal. Diagonal elements are A1, A2 and AN. Okay? B involuntary matrix. ಏನಾದ್ರೂ ಇದು involuntary matrix ಅದ. Okay? If it is involuntary matrix, A square must be equal to identity matrix ಬರಬೇಕಾ? A square equal to I ಬರಬೇಕು. Okay? What is A square here? A square equal to square of the diagonal elements ಅದಲ್ಲಿ. Therefore, A1 square, A2 square and so on, AN square. That is must be equal to ಏನಾದ್ರೂ ಇಲ್ಲಿ identity matrix ಅದ ನೋಡ್ರಿ. ಅದಲ್ಲ I square equal to in ಅದ. But what is in? In is also diagonal matrix, so diagonal elements are 1. I hope all of you understand. A square equal to I. then these two matrices are equal adavri. This implies that AI square is equal to AI. Corresponding elements must be equal, sorry, A1, not AI. 1. Because here diagonal elements are 1 are there. Here diagonal elements are AI square is there. Therefore, diagonal elements must be equal, Rebecca. AI square equal to 1. This implies that AI equal to plus or minus 1. Just one AI square equal to 1, AI equal to plus or minus 1. This implies that here we take any diagonal involuntary matrix, then we get AIs are either 1 or minus 1. Okay. Then each AI has two possibilities are there. 1 and minus 1. A has two possibilities. A2 has two possibilities. AN has two possibilities. Then total how many possibilities are there? How many possibilities are? 2 into 2 into how many times? N times. Therefore, the number of diagonal involuntary matrix is equal to 2 raised to n. Unit 2 raised to n. Okay? Of order n iddakraga. Suppose how many diagonal involuntary matrix of order 5 n equal to 5 ಕೊಟ್ಟದ ಏನು ಕತ್ರ ಅವಾಗ 2 raised to 5 is equal to 32. Okay? They given you n here. Then you can easily find out the number of diagonal involuntary matrix. Hada? Then these results are very important for KSET and NET exam. But example ಯಾವ್ದು ನೋಡ್ರಿ ಸ್ಪೆಷಲ್ ಕೇಸ್ ಆಫ್ ದಿ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ದಿ ಇನ್ವಾಲಂಟರಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಇಲ್ಲಿ ನೋಡಿ ಏನ್ ಮಾಡ್ತೀನಿ ಜನರಲಿ it is 4 by 4 matrix is there. The 1/4 position is A, then 4th one position 1 by. ಹೌದಾ? Next ಇಲ್ಲಿ 2/3 position is B, then 3/2 position is 1 by B. ಅಂದ್ರೆ reciprocal. ಈ ರೀತಿ ಇದ್ದು ಅಂದ್ರೆ ರಿಮೈನಿಂಗ್ ಆಲ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ 0. ದೆನ್ ಆಲ್ಸೋ A square ಏನು ಬರ್ತದೆ ರೀ? ಐಡೆಂಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಬರ್ತದೆ. Because this 1/4 element is multiplied to 4/1 position. Okay, 1 by A into A ಏನಾಗ್ತದೆ ಇಲ್ಲಿ ಅವಾಗ 1 ಆಗ್ತದೆ. ದಟ್ ಈಸ್ ದ 1/1 position 1 ಬರ್ತದೆ ಅಲ್ಲಿ. ಓಕೆ, ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ನೋಡ್ರಿ ನೀವು ಇಲ್ಲಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡ್ರಿ, ನಾ 2 by 2 ತಗೋತೀನಿ ನೋಡ್ರಿ. ಇಲ್ಲಿ A equal to ಈ ರೀತಿ ತಗೋತೀನಿ ನೋಡ್ರಿ, 0 0. ಇಲ್ಲಿ A ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ 1 by A ತಗೊಂಡಿರ್ತೀನಿ. ಓಕೆ, ದೆನ್ ಸ್ಕ್ವೇರ್ ಇಟ್. ಸ್ಕ್ವೇರ್ ಮಾಡಿ ಯಾವ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಬರ್ತದೆ ನೋಡ್ರಿ. ಈಗ A ಸ್ಕ್ವೇರ್ ನೋಡಿ ಏನು ಬರ್ತದೆ, 0A 1 by A 0. Then ಇಲ್ಲಿ 0A 1 by A 0. Then multiply. First row first column 0 into 0 0 plus A into 1 by A 1. Next first row second column 0 into A 0. A into 0 0. ಈ 0 ಬಂತು ನೋಡ್ರಿ. Second row first column 1 by A into 0 0. 0 into 1 by A 0. Next second row second column 1 by A into A 1 plus 0 into 0 0. That is 1. ಏನು ಬತ್ರಿ ಇದು? ಐಡೆಂಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಫ್ ಆರ್ಡರ್ 2. A square equal to I2. This implies A is involuntary matrix. ಸ್ಕ್ವೇರ್ ಮಾಡೋಣ ಐಡೆಂಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಬರ್ತಿತ್ತಂದ್ರೆ that matrix is involuntary matrix. ಓಕೆ, ಮತ್ತೆ ಇಲ್ಲಿ ಏನ್ ಬೇಕಾಗ್ತವ್ರಿ? ಈಗ ಇಲ್ಲಿ 2 ತಗೋರಿ, ಇಲ್ಲಿ 1 by 2 ತಗೋರಿ. ದಟ್ ಈಸ್ ಎನ್ ಇನ್ವಾಲಂಟರಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ದೆನ್ ಇಲ್ಲಿ 2 ತಗೋರಿ, ಇಲ್ಲಿ 1 by 2 ತಗೋರಿ. ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಇನ್ವಾಲಂಟರಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಹೌದಾ? ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ 3 ತಗೊಂಡ್ರಿ ಅಂದ್ರೆ ಇಲ್ಲಿ 1 by 3 ತಗೋಬೇಕು. ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಇಟ್ ಈಸ್ ಎನ್ ಇನ್ವಾಲಂಟರಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್. If you want to take 3 by 3 matrices, Okay, then also true. ಏನಂದ್ರ if you take ಇಲ್ಲಿ here any n by n matrix ತಗೊಂಡ್ರಿ ಅಂದ್ರೆ ಇಲ್ಲಿ 1 2 ಪೊಸಿಷನ್ ದಾಗ ಇಲ್ಲಿ ನಾವು ಇಲ್ಲಿ ಎ ತಗೊಂಡ್ರಿ ಯಾವ್ದಾರಿ ಪೊಸಿಷನ್ 1 3 ಅದು ಅಂದ್ರೆ 3 1 ಪೊಸಿಷನ್ ಗೆ 1 by a ತಗೋಬೇಕು ಇದು 1 3 ಅಂದ್ರೆ ಫಸ್ಟ್ ರೋ ಥರ್ಡ್ ಕಾಲಮ್ ದಾಗ ಎಷ್ಟು ಅದ್ರಿ ಎ ಅದು ಹೌದಾ ಏನ್ ತಗೋಬೇಕು ನೀವು ಇಲ್ಲಿ 3 1 ಪೊಸಿಷನ್ ಅಂದ್ರೆ ಯಾವ್ದ್ರಿ ಥರ್ಡ್ ರೋ ಫಸ್ಟ್ ರೋ ಸೆಕೆಂಡ್ ರೋ ಥರ್ಡ್ ರೋ ಫಸ್ಟ್ ಕಾಲಮ್ ದಾಗ ಎಷ್ಟು ತಗೋಬೇಕು ನೀವು ಇಲ್ಲಿ 1 by a ತಗೋಬೇಕು ಹೌದಾ ಇಲ್ಲಿ ನೀವು ಸಪೋಸ್ ಇಟ್ ಈಸ್ 2 4 ಪೊಸಿಷನ್ ಈಸ್ ದೇರ್ ಇದಕ್ಕೆ ತಗೋತೀರಿ ಬಿ ತಗೋತೀರಿ ದಿಸ್ ಪೊಸಿಷನ್ ಈಸ್ 2 4 ದೆನ್ ಇದು ರಿವರ್ಸ್ ಯಾರು ಆಗ್ತದ್ರಿ 4 2 ಪೊಸಿಷನ್ ಏನ್ ತಗೋಬೇಕು ನೀವು ಇಲ್ಲಿ 1 by b ತಗೋಬೇಕು 4 2 ಅಂದ್ರೆ ಯಾವ್ದ್ರಿ ಫೋರ್ತ್ ರೋ ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಥರ್ಡ್ ಫೋರ್ತ್ ಸೆಕೆಂಡ್ ಕಾಲಮ್ is 1 by b and remaining all elements are 0. Okay, then that matrix is also an involuntary matrix. Okay, I hope all of you understand this concept. Then ಈಗ ರಿಸಲ್ಟ್ ನೋಡ್ರಿ if a is involuntary a square equal to a ಬಂತು sorry I. What is aq? Pre-multiplying on both sides by a into a square is equal to a into I. This implies a cube equal to n by 3 a ಬಂತು ನೋಡ್ರಿ next again you pre-multiplying a into a cube is equal to a into a ಹೌದಾ then a into a cube is a raised to 4 is equal to a square but a square is I a square n by 3 I ಬಂತು ನೋಡ್ರಿ next a raised to 5 ಬರ್ತದೆ ನೋಡ್ರಿ a raised to 5 is a raised to 6 is a square into a square ಏನ್ ಬಂದ್ರಿ again I. ಓಕೆ ಇದೇನ ನೋಡ್ರಿ ಇಲ್ಲಿ u1 ಪವರ್ ಏನ್ ಬರ್ತದೆ ಇಲ್ಲಿ we take u1 power identity a raised to a square is I a raised to 4 is also I a raised to 6 is I therefore a raised to 2n is identity matrix a raised to 2n is identity matrix. Okay, then what is the odd power nodri a raised to cube is a raised to 5 is also a raised to 7 is also a then a raised to odd power 2n minus 1 is always a. ಗೊತ್ತಾಯ್ತಾ if a is any involuntary matrix ಇತ್ತಂದ್ರೆ a raised to even power is always identity a raised to 4 a raised to 2 lakh is also identity. Okay, I hope all of you understand this concept. This is very important for your NET exam and as well as KSET exam. Okay, ಇಲ್ಲಿಗೆ ಸ್ಟಾಪ್ ಮಾಡೋಣ್ರಿ ಏನಾದರೂ ಅಡಚಣೆ ಇದ್ರೆ ನೀವು ಆಮೇಲೆ ಬಂದು ಕೇಳ್ರಿ ಮತ್ತೆ ಹೌದಾ ಥ್ಯಾಂಕ್ ಯು ಆಲ್ ಆಫ್ ಯು.